Okay, your bell ringers are on the board. The sub will have those up there. Then it should be paused here for a few minutes. That way you can get started on it. So remember from our notes yesterday when we did square root equations, when we graphed those, you have to pick points for your XY chart that work well in the root. Okay, so for my first one here, my A, I would probably pick numbers for x that make this a nice square root. And nice square roots are going to be 0, 1, 4, 9, and 16 would be some nice ones. Okay, and remember, since it's a square root, you can't have negatives in there. So I would pick numbers that would make the stuff underneath the square root a 0, a 1, etc. Okay, so if I had a -2, that would give me a 0 underneath here. Okay, so a -2 in there. That gives you a 0. 3 times 0 is 0 plus 4. So your first point is -2, 4. Okay, so then I'm going to keep going, picking points that would make that a nice root. Okay, next one I'd probably pick is a -1. And then that gives me a 1 underneath there. So it'd be 3 times the square root of 1, which is 3 plus 4 is 7. Okay, and then I'm going to pick a 2 next. Because it'd be 2 plus 2 is 4. Square root of 4 is 2, so that would be 3 times 2, which is 6 plus 4 is 10. And I'm just going to pick one more point here. Okay, I want that to be a 9 underneath there, so I'm going to pick a 7. So it'd be 3 times square root of 9, which is 3, so it'd be 9 plus 4, which is 13. So then I'm going to graph those. So -2, 4 is going to be here. -1, 7 going to be there. And then 2, 10 going to be there. And then we have 7, 13. Going to be kind of about up here. So you can kind of get that general curve of your square root function there. Okay, and then you can see your starting point is there. So your domain is going to be right of that starting point. So we're starting at a -2, what we chose for our XY chart, so your domain is going to be x is greater than or equal to -2. For the next one over here, we're going to have to try to think of our points again. So numbers that make that a 0, 1, 4, 9, and so on. So I'd say the first one I'm going to pick is a 3. And then the next one I'm going to pick is a 4. And then the next one I'm going to pick after that is going to be a 7. Next one I'm going to pick after that is going to be a 13, nope, a 12. Okay, because 3 minus 3 gives me a 0. -2 times 0 is 0, so we're starting at 3, -4. 4 minus 3, that's a 1. So it's -2 minus 4 is -6. 7 minus 3 gives you a 4. So square root of 4 is 2. -2 times 2 is -4 minus 4, so it's -8. And 12 minus 3 gives you a 9. Square root of 9 is 3. So that gives you a -6 minus 4 is -10. Okay, so we can graph those points. I might be running off the screen here. So 3, -4, 4, -6, and 7, -8. Be about there, and then 12, -10, so that's going to be kind of way down there. So your graph is going to be like that. So you can see our starting point is right here, which is that 3, -4. So your domain here is x is greater than or equal to 3. Okay, so that's our graphs. You guys are going to need to know how to do that on the test. Okay, on the next one. Okay, go ahead and take a few minutes to write these down. So please pause the video, and we'll keep going from there. All right, steps for solving radical equations. The first thing you want to do, this is really important, you have to take the steps to isolate the radical expression. So that means get that square root, cube root, whatever it is, get it by itself. Okay? And then you're going to have to square or cube both sides, or whatever you need to do in order to get rid of that root. So if it's a square root, just like that, then you're going to have to square both sides. If it's a cube root like that, then you're going to have to cube root both sides. If it's bigger, like a fourth root, then we're going to have to take the fourth power of both sides. Depends on what the root is. Okay, once that radical's gone, then you solve for the variable that you're looking for and check your answer. Okay, because sometimes you could get a negative underneath that square root or that fourth root and it won't work. Okay, so since we have isolated the radical here, we don't have to do anything. First thing we start with is cubing both sides. Okay, so then that is going to get rid of that. So our radical disappears. And then we got 3 cubed, which is 27. So from there, it's just a straightforward equation. So minus 7, so you get 2x equals 20, x equals 10. And you're done. So if we plug that thing in to check it, that's going to give you 20 plus 7, so it's a cube root of 27, which is 3, so it works. All right? Go ahead and write that one down. Okay, steps to solving this one. We don't have the radical by itself yet, so that means we have to move that negative 9 over because it's not underneath the radical. You add 9, then you have cube root of x equals 8. So then from there, what do you think you got to do? We got a cube root, so how do we get rid of that? Cube both sides. So you have x equals 8 cubed, and I think that is 256. Alright? So then, if you check that one, should be good. Because it'd be cube root of 256, which is 8 minus 9, negative 1. Alright, so when we have radical exponents or rational exponents, I want you guys to take a few minutes to write this stuff down. Okay, so you're going to isolate the term with the rational exponent. So that is the same as isolating your radical. Oh, going back on this last one. It's not 256, it's 512. Okay, going forward here. Isolate the exponent there, or isolate the term with the exponent. That is this x here. Okay, we got to get that by itself. Well, that means we have to get rid of that 4. So divide both sides by 4. Okay, so then now we have that x to the 3/2 isolated. Okay, 108 divided by 4 gives you a 27. Okay, so from there, you got to think of, well, that x, well, that's a square root of x cubed. How do we undo that? Well, you could square both sides, but then that's going to make our 27 massive, and we're going to have to take the cube root of that eventually anyway to get rid of the x cubed. Easier way. So I can raise both sides of this equation to a reciprocal power. Okay, because if you're looking over here now, what happens to those powers? Well, you're going to multiply exponents. 3/2 times 2/3, they'll just cancel out. So we have x to the first power over here, and we have 27 to the 2/3. Okay, well, you can evaluate 27 to the 2/3. That's a cube root of 27, so let's change the cube root of 27 squared. Cube root of 27, that's a 3 squared, so your answer is just a 9. Okay, and if you plug a 9 in there, that's going to work. Okay, next example. Go ahead and write that down. Okay, so looking at it, the thing that we have to isolate now is that. We have to get that by itself because that is the thing with our power. Okay, we have to get that by itself. So, easy step to get rid of that 1. So you have x plus 2, 3/4 power, and you got an 8. So now what do you think you're going to have to do? What power are you going to raise it to get rid of that 3/4? Well, what's the reciprocal of 3/4? That's 4/3. 4/3. Okay, that's going to take care of that on the left. We have an x plus 2 on the left. And on the right, we have cube root of 8 to the 4th power. You can change it to that. You can change it however you want to. You'll actually be able to use your calculator on these ones on the test, so you can use your calculator. But I think it's easier to do it in your head. Cube root of 8, 2 to the 4th power. That gives you 16. So it's x plus 2 equals 16. And then you get x equals, so you subtract the 2, you get a positive 14. Okay, so x equals 14. So that's another one with fractional exponents. Okay? So here are a few, we'll just do these two. Here's a few practice problems. I want you guys to try these two. Okay, then I want you to try this one right there. Alright, so please pause the video for a little bit. Have everybody try to work through those. They can compare answers at their table. And I'll show the answers here in a minute. Okay, number 1. Pretty easy. Add 2, you got square root of x equals 7. How do you get rid of that square root? You're going to square both sides. So you got x equals 49. Pretty quick. Okay, you only have to move one thing over, then square both sides. So over here, number 2. So same kind of deal. We got to move the 5 over because we want to get that radical by itself. Okay, so I'm going to subtract 5. I got x plus 1 underneath the radical equals 11. Then you got to square both sides. So that gets rid of your radical. So it's x plus 1 equals 121. So minus 1, you get x equals 120. Okay, not too bad. So number 3. We got to get that x to the 1/3 by itself. Alright, so same kind of deal as we did on the last problem. We got to move that regular number over. So add 4. X to the 1/3 equals 4. So now we got that rational exponent. How do we get rid of it? Okay, well 1/3, what's the reciprocal of 1/3? That would be a 3 over 1, or a 3. So that means you're going to cube both sides. That would turn it to x equals 4 cubed, or x equals 64. Alright, not too bad. Okay, if you want to pause the video, everybody can stand up, stretch out for a minute, and then we got a few more examples left. Alright, next thing here. So you're looking at this equation and you're like, well, I got the square root by itself, but I got an x plus 1 on the left. How do I do this? Well, it's the same steps. Okay, so isolate the radical, done. Get rid of the root. So that means we have to square both sides. That means we have to square this entire left side here. Now, this is not, you can't distribute that exponent like we talked about on the last test. It's not x squared plus 1 squared. Can't do that. Okay, you have to FOIL it out. So this is really x plus 1, x plus 1. So that's where these patterns are going to come in handy again. So it'd be x squared plus 2x plus 1 equals 7x plus 15. Okay, that's what that would FOIL to. Okay, people need to pause the video, that's okay. You can pause it at any time and look backwards to see what we did. But from here, we got an x squared and an x, and remember from the last couple chapters I said anytime you have an x squared and an x, that means you're going to have to factor. So that means we have to move everything to one side, set it equal to 0. Okay, so that means minus 7x x squared minus 5x plus 1 equals 15. Now we got to move the 15. Okay, so it's x squared minus 5x minus 14 equals 0. So now this stuff right there is what we have to factor. So that's just a normal factor problem. You have two numbers that multiply to give you a 14 or negative 14 and add to give you a negative 5. So that's going to be x minus 7, x plus 2 equals 0. So now you get two answers. So that means we have an x equals 7 and an x equals negative 2. This is really where it's important to check your two answers. Okay, so if you plug the 7 in there, it's going to look like this. It'd be 7, 7 plus 15, so it's square root of 64, which is the 8 that we would get on the other side. Okay, now if we put the negative 2 in there, so we have 7 times negative 2 plus 15 square root. That's going to give us a negative 14 plus 15, so it gives you square root of 1 on the right-hand side. If we plug the negative 2 over here, negative 2 plus 1 is a negative 1. So does the square root of 1 equal a negative 1? No. So that's not an answer. X equals 7 is your only answer. Okay? So I want you guys to go ahead and practice one like that and see what you get for answers. Okay, so go ahead and pause it, have people practice it. And back at the example. So, isolate the radical, that's done. So then we square both sides. So that gets rid of my radical. And then I'm going to square that one, so it's x squared minus 14x plus 49 if I use my pattern. Okay, move the x over, move the 1 over, I get 0 equals x squared minus 15x plus 50. So that should be a pretty easy one to see. 10 and 5, both negatives. Okay, if you check them, so x equals 10, x equals 5. The one that's going to work is the 10. The 5 will not if you check it. Okay? And to the final example here. It looks a little bit crazier. Okay? So this one, you got to look at it. And we're going to be like, okay, well, we got a square root on both sides. Isolate the radical. Well, if you try to isolate the one on the left here, that means you're going to move the 1 over, but you're still going to have a radical on the other side. So it's just going to keep going back and forth. So first thing you got to do is square it. You're going to square both sides. Well, squaring the stuff on the left is going to look like this. And squaring the stuff on the right is going to be pretty easy. So you got to FOIL this stuff on the left-hand side here. So if you take that one times that one, you're just going to get an x plus 2, because that really just gets rid of your radical. And then you're going to have plus square root of x plus 2. And you're going to have plus square root of x plus 2. And then you're going to have plus 1 equals 3 minus x. Now you're going to have to isolate that radical again. So that means we have these two. That gives us 2 square root x plus 2. And I'm going to move the other stuff over to the left. Minus 2, minus 2. So that's 3. That just gives us a 0. And a negative 2x over there. So here, get that radical by itself. Divide by 2. Divide by 2. Square root of x plus 2 equals negative x. Then from there, you got to square both sides. And you should be able to finish it from there. Okay, we can go through this one on Thursday, but your answers are going to be x equals 2 and negative 1. The 2 doesn't work, the negative 1 does. Okay, try to finish that one out if you can. And your homework is that. Okay, give it a shot.